Hey everyone, welcome back, and today let's solve Leetcode problem 1963 titled Minimum Number of Swaps to Make the String Balanced. So we're given a zero-indexed string S of even length n, and the string consists of exactly n half opening brackets and n half closing brackets. And a string is called balanced if and only if it is the empty string, or it can be written as AB, where both A and B are balanced strings, or it can be written as C, where C is a balanced string. And we may swap the brackets at any two indices any number of times, and we have to return the minimum number of swaps to make S balanced. So in example 1, we have S to be an input string of the following, and we'd output 1 because we can make the string balanced by only having one swap, swapping index 0 with index 3, and so the resulting string would be these nested brackets that are considered to be valid. And in example 2, we have S to be an input string of the following, and in this case we would output 2 because we can do the following to make the string balanced. First, we swap index 0 with index 4, that's one swap, and the resulting string would look like this. And then for our second swap, we'd swap index 1 with index 5, and so our final resulting string would look like this, which is considered to be valid. And so that's why we'd output a total of 2 swaps. And finally, in example 3, we have S to be an input string of length 2, where we have one opening bracket being closed right after it or consecutively by a closing bracket, and so this string is already considered to be valid or balanced, and so we wouldn't have to need any swaps to balance it any further, and so we'd output 0 because again it's already balanced. So with the problem statement and the examples out of the way, I will give you guys a few seconds to kind of just go over this problem in your head and think of a valid solution, and then I'll show you guys how I would optimally solve this problem. Alright, so we'll use a Grady algorithm to solve this problem efficiently, where the key concept is basically to track the imbalance of brackets as we traverse through the string. And every time we encounter a closing bracket without a matching opening bracket, we'll add to the imbalance. And our goal is to reduce this imbalance by counting the maximum imbalance at any point and determining how many swaps are necessary to fix it. So, of course, we're going to be using an imbalance variable, which is basically going to track the current imbalance of brackets while traversing the string for every iteration. And we'll have a max imbalance, which will store the maximum imbalance encountered during traversal for every iteration. Okay? And each swap will basically fix two imbalances, and thus we can calculate the minimum number of swaps required to balance the string by halving the maximum imbalance. Okay? Because, again, we take only one swap to swap two imbalanced brackets at two different indices. Okay, so with that out of the way, let's just go ahead and dive straight into the code. So first we'll have our imbalance variable like we talked about just now, and that's going to be initialized to 0. Okay, and basically again, this variable keeps track of the net difference between opening and closing brackets as we traverse through the string, and a positive imbalance means that there are more opening brackets than closing brackets, while a negative imbalance means that there's more closing brackets than opening brackets. And so we'll have a max imbalance, and this is also going to be initialized to 0. Again, this is eventually going to store the maximum negative balance as we encounter, basically the maximum negative balance we encounter during the traversal, and it's very important because it helps us determine how basically bad the imbalance gets, which we'll later use to calculate the number of swaps needed to balance the string. So now let's actually just iterate through the input string S. I'm going to say for, I'll just say ch or character in S. I'll basically check if ch is actually equal to a closing bracket, then we know immediately that we can increment our imbalance by 1. Okay? Basically, we'll increase the imbalance by 1, and the reason why is because an opening bracket adds to the number of unbalanced brackets that need to be closed later on in future iterations as we traverse through the array, right? That increases or increments our number of imbalanced opening or closing brackets by 1, okay? And sorry, this is an opening bracket, not a closing bracket. Just keep that in mind. And we'll say else. This basically covers the case when we actually have a closing bracket. Then we'll decrement our imbalance by 1. We'll say imbalance minus equals 1. Again, we'll decrease the imbalance by 1 as a closing bracket can cancel out a previously seen opening bracket. However, if there's no matching opening bracket, this will make the imbalance negative, which does indicate an overabundance of closing brackets. Okay? And again, for every iteration in this for loop, we'll set our max imbalance to be equal to the minimum value of course, itself, because we don't want to make it larger, and the imbalance in this current iteration, right? Basically, we're going to update this variable to be the minimum of its current value and the imbalance, and we'll use a minimum, and not maximum, because we're interested in the largest negative value or smallest value of imbalance, because that's where the string is most unbalanced, and a more negative number means a worse imbalance or a more bad imbalance. And ultimately, outside of this for loop, once we're done with every single iteration of our input string s, we can return the negative max imbalance, add 1 to that value, and integer division that by 2 to return that ultimate value. And so unless I made any syntax errors here or I spelled something wrong, this should be accepted. Okay, let's see what I did here. Imbalance. Oh, there should not be an A here. Sorry. And now this should be accepted. And as you can see, this is just about as efficient as you can get. And just to better explain line 11, since each swap corrects 2 imbalanced strings, we basically calculate the number of swaps needed by taking the negative of the max imbalance to make it positive, and then adding 1 since we want to have the ceiling of the division and divide that by 2. We could use math.ceil. It doesn't really matter. I just added 1 to better easily seal this for division. But this basically gives us the minimum number of swaps needed to fix the imbalance, because again, we only need 1 swap to fix 2 imbalanced strings from 2 different indices. So basically, again, what the code overall does, it basically calculates the minimum number of swaps required to balance a string of square brackets, and it first traverses the string and tracks the imbalance between opening and closing brackets using that imbalance variable. And the worst case, basically most negative imbalance, is recorded in the max imbalance variable, and the number of swaps needed is going to be half of this value, of course still divided, because 1 swap again fixes 2 brackets. So for the time complexity of this algorithm, it's going to be big O of n, or linear time, where n is going to be the length of the string s, and that's really only because we only make a single pass or a single traversal through the input string. And for the space complexity, this is going to be big O of 1, or constant time, because we only use a few integer variables like imbalance and max imbalance, and which don't grow regardless of the input size, right? We don't actually use any extra data structures to store any elements or inputs from our input string s. So if you guys enjoyed this solution and learned something new, please consider liking this video and subscribing to my channel. And without further ado, I will see you guys in the next video. Bye-bye.